Welcome to adding and subtracting relating to length. So some prior skills that you've had to this unit would be adding and subtracting a 99 using various strategies, and you've also done some measurement. So now we're going to look at the number line, which is a linear model to add and subtract. So we'll start with the problem 38 plus 57. You can choose to start your open number line from 38 or 57. Eventually, we want students to think about it would be more efficient to start at 57, but it's not wrong for them to start with 38. I'm going to start with 57, but we want students to think about the opposite add-in. How can I decompose that add-in? There are plenty of ways that I can decompose 38, but if I think about 38, I know that I'm 3 away from the next 10 at 57. So if I can decompose that 8 to have 3 more, so I can get to 60, that's going to help me. I know that 8 is decomposed into 5 and 3. And then I know 30 is decomposed into 3 groups of 10. The big piece that you would want to hit on here is that it really doesn't matter how they decompose it, as long as it adds up to the value, and then we'll help shore up the decomposing to actually help them get to the number that they're looking for, because sometimes the numbers that they pick might be more difficult to cross over tens. So if I'm at 57, I know that I can choose to go with my tens first. I can make one large jump of 30, which would get me to 87, but most of the time students like to start with 3 small groups of 10. There's nothing wrong for them to do 3 groups of 10. That's at 30. 3 groups of 10, but they also could make one large. We would try to get them to more efficiently making one large group of 30. Then next, we would try to jump to our next group of 10, or our next multiple of 10, which is 90. And then I would have 5 left to get me to 95. And so this would be one of my add-ins. My other add-in should be able to be seen here, which is 38, and then my sum is 95. And part of the battle is being able to interpret that diagram to help them solve. So we'll shift over to subtraction. If I start with 45, this is just one way that I could do it, and I'm going back 17. Again, I'm going to want to try to decompose 17. I know I'm at 45. So if I think about 7 being broken apart into 5 and something, I know that it's 5 and 2. That's 7. I also have my 10. So 10 plus 2 plus 5, all of that equals a value of 17. So I can use this to help me move on the number line a little bit more efficiently. So I can choose to go ahead and go back my 5, or I could go ahead and jump my 10. This would get me to 40. I know that I need to go back 10. My 30, and then I also have 2 left, that if I count back 2, I end at 28. In this case, this is my difference. I traveled a distance of 17, and I started at 45. Another way that you could look at this exact same problem is to think addition. A lot of students connect with addition easier than they do subtraction. So they could actually start at 17 and try to get up to 45. So some might be able to make groups of 10, 27, 37, knowing that I can't get to my next group of 47 because I'll go over. I've got 3 to get me to my next group of 10, which is 40. And then I've got 5 to get me to 45. Again, going back to the interpretation of this model is what matters. This is what my starting point was in the problem. This was my ending point in the problem. I just chose to count up. The answer is actually going to be found here, 10, 20, 28. So same idea, but they need to be able to interpret the model for what they're using it for. And the big key here is going to be flexibility with numbers, just practicing breaking apart numbers in multiple ways so that they can choose the most efficient way to break it apart when it's time to solve.